Okay. Thank you for joining us today. My name is Allison Ban, and I'm the Executive Director at SPARK, a Center for Social Research Innovation. Welcome to today's SPARK Talk, Improving the Measurement of Sensitive Survey Questions with Double List Experiments with Gustavo Diaz. I'd like us to begin by giving honor and thanks to the Haudenosaunee and Anishinaabe nations as the traditional inhabitants of the lands where McMaster stands. To say that is to acknowledge a debt to those who were here before us and to recognize our responsibility as guests to respect and honor the intimate relationship that Indigenous peoples have to this land. Gustavo Diaz is a postdoctoral fellow in the Department of Political Science here at MAC. Research develops standards to navigate research design trade-offs in the social sciences with special interest in questions related to the challenges to democracy and representation in the global South. Thank you so much for joining us today, Gustavo.
Thank you. Thank you for the opportunity to present. And I don't know if I'm sharing my screen right now.
Not yet.
Okay. How about now?
Yep.
Okay, my full screen. Thank you for people joining online, and thank you also people watching this in the future. So this talk is a mix of my own work, and I need to move things around Zoom a little bit. Sorry about that. There you go. This talk is a mix of my own work and recent developments on these experiments, mostly about double list experiments. So the main takeaway is going to be if you are thinking about using these experiments because they're interesting in measuring or asking sensitive questions in surveys, you should think about double list experiments. And I'm going to talk to you about a few things you should keep in mind if you want to do that. So we can start, and I know we have people in the room and we have people on Zoom, but we are a small group, so we can, if we have questions or things we want to talk about on the way, I'm happy to have a conversation. Let me start with what I think is a head scratcher, and we are being trumped a little bit by recent events. So something that happened recently is that the government of Canada removed a lot of the COVID-19 border and travel measures for protecting the border from COVID. And one thing they did is they got rid of the Arrive Can app. If someone is watching this and is not in Canada or hasn't been in Canada recently, this was the app that the government required people to use and fill with information about their vaccination status and current symptoms before entering the country. That's not a thing anymore since October 1st, but I still think it's a good head scratcher for us to think about how we ask questions and what kind of questions we ask. So this is how the app looked like. In your left-hand side, you see how the form begins, and it's asking you to put your vaccination information and all of those things. And right before you travel, you're usually asked to complete this self-assessment, or we're asked to complete this self-assessment. Are you or any of the travelers listed on the form experiencing any of the following symptoms? And it's the usual COVID-19 symptoms that we're used to and have been screening for more than 2 years now. So what's censored there is just the name of a person. And if you have multiple people, you would have multiple entries for answer yes or no for all the different people in your party. But what I think it's a head scratcher to me is when I look at these kind of questions, I ask myself, what would be the proportion of people who are using the app who are answering yes to having symptoms? Do people in the room have a guess?
Extremely low.
Extremely low, right? So when I was thinking about this, I was walking through the steps of what are the options that people have. If you're not sick, if you don't feel sick, you answer no, and that's fine. That's the end of it. But if you are sick and you have symptoms, you have two options. you don't travel, so you don't have a reason to use the app, and you don't have a reason to answer the questions, or you lie about having symptoms and travel anyway. So when I think about it, and the reason why I think this is a head scratcher is because when I see these questions, I'm like, who's gonna say yes to this? Who's gonna actually answer this question in the way we want to? And I like this example because public health is important, and we ask these questions, and we see these questions all over the place in a lot of different fields. And from a social science perspective, we use surveys a lot. Many of the questions we ask in surveys are too sensitive to ask directly, but we ask them anyway. We could just say, let's not ask those questions because they're too sensitive, but these are important things. These are things we care about. So just to give you a few examples, I'm a political scientist, so a lot of the things that we read about sensitive questions in political science have to do with racial prejudice, with support for rebel groups in context with civil conflict. I know in sociology and economics to some extent, they care about sexual and reproductive behavior. So these are things we want to know about, we want to learn about them, but we can't just go and ask these questions directly. And this is something we have known, this is a problem we have known for decades. And there is a lot of techniques that rely on asking indirect questions to get honest answers while still protecting the anonymity of those who are participating and taking our surveys. So the one technique that I want to talk about today, if you are here, you already know what we're talking about, is list experiments. So this is how list experiments usually look like. And this is one example from a validation study in Mississippi. So they usually start with the header. Here is a list of things that some people have done. Tell me how many of them you have done in the past 2 years. Do not tell me which ones, just tell me how many. That last part, they did not tell me which ones, comes from the time where most of the surveys were over the phone. So what used to happen is that as the enumerator over the phone was listing the things, people were saying yes, no, yes. So they really have to stress that for this to work, they don't need to know specifically which ones, just how many of them. So in this case, they asked, so this is an experiment. So the experiment part of this is that people are being randomly split between treatment and control group. So in the control group, this is the list that people see in the control group. Discuss politics with family or friends, cast a ballot for Governor Phil Bryant, who was the governor of Mississippi between 2008 and 12, if I remember correctly. Paid dues to a union and given money to a Tea Party candidate organization. That's the control group. The treatment group, what they see is the sensitive attitude or behavior that we care about, which in this case is voting yes on the personhood initiative on the November 2011 Mississippi general election ballot. This personhood initiative, as the name suggests, was a constitutional reform in the state that was trying to redefine what the meaning of what a person is, mainly to make it illegal for people to have abortions, for women to have abortions. Now, the wrinkle is that Mississippi is generally a conservative state. So most people were socially expected to maybe vote yes, but so the actual sensitive behavior that we care about is not the yes part, but the people who voted no. Because the puzzle here is that even though Mississippi is a conservative state, the no vote is the no alternative is the one that won. So what do we get out of this exercise that it feels like a weird play on words and a weird way to ask questions? So what we get is an estimate of the prevalence of the sensitive attitude for behavior. So let's call that X to keep it simple. So the prevalence of X from a list experiment is the mean of the responses who got the list with the sensitive behavior included, minus the mean of those who got the list without the X. Then the difference in means between treatment and control that standard experiments fair. In this context, we interpret that prevalence estimate as the proportion of individuals in the target population who hold the sensitive attitude or behavior of interest. And the main feature of doing these experiments is that we're obtaining that population estimate without knowing the individual responses. So the guarantee here is that neither the researcher nor the enumerators know what individual responders are answering, but because we're doing things in this way, we know that we have a general sense of the population, and if our sample is good, then it's going to be a good approximation of the prevalence rate of the sensitive behavior or attitude in the population. The main advantage of asking questions this way is that it's reducing what we call sensitivity bias. And the reason why I wanted to talk about this validation study is because what you're seeing in this figure, and because it was at least experiments based on an election that led to an outcome, is that we know the result. So that we know for the counties that were sampled for this survey, that the no vote, that's what you're seeing in the vertical axis, is the estimated proportion of no votes. We know that the actual no votes for the countries in this study were about, counties in this study were about 65%. 65% of the people voted no. I don't care about the endorsement experiment and randomized response part of it for now. I also don't care too much for the purposes of today about this distinction between unweighted and weighted and adjusted estimates at the bottom. What I do care about is the distinction between the two different kinds of estimates with direct questions and with the elicit experiment. So what this figure is saying here is that when you ask people directly, did you vote no, only 40% of the people say admit openly that they voted no, even though we know that there's like a 25% gap there, that actually 65% people or so did vote no. When we do a elicit experiment, we get point estimates that get closer to the actual vote share. So that's what we call a reduction in sensitivity bias. We're still not there, and there are ways we can get closer to the actual responses. But what we're seeing here is an improvement. We're getting closer to the actual vote share. The downside of this is that this increases the variance of the estimates. So here we have two boxes around the two different groups of estimates, and that's roughly wrapping the confidence intervals. So you can see that the box on the left is a little bit shorter than the box on the right. So that means that for the elicit experiments, we are getting more precise answers that are closer to the actual vote share, but that are narrow, that had wider confidence intervals. So that means that we're getting closer, but we're being less precise about what exactly is the proportion. That means there's a bias variance trade-off. And the bias variance trade-off is an idea that appears pretty much everywhere where there's statistics involved. And the trade-off here is between, do you want to invest in doing a elicit experiment because it's going to get you closer to the real answer at the cost of some variance of wider confidence intervals in your estimates. So these are simulations from recent work in the American Political Science Review, and they are walking us through two kinds of decisions. The left panel is about, do you want to do a elicit experiment, or should you just settle with asking questions directly? So in the vertical axis, they have the sensitivity bias in percentage points. That would be the gap between those who would admit to the sensitive behavior with direct questions versus those who would only do so if they're asked the elicit experiment question. And the root means per error part here is just a metric that we are using in simulations to know how close we're getting to the actual answer. So what this figure is basically saying, these are indifference curves. So above the line, the error from the direct questions is bigger than the error from the elicit experiment questions, and we want that to be, we want error to be small. So above that line, you prefer elicit experiment over direct questions, but below the line is the other way around. You're better off asking direct questions because of this bias variance trade-off. So what we're getting out of this is, for example, that if you have 1,000 respondents, which used to be, depending on your field, that's either a very normal amount of responses to get. It's more or less standard in political science nowadays. In other fields of social science, that's a ridiculous amount to ask for. So take it for, like take that in the context of what you're gonna apply this to. If you have 1,000 participants in your survey, the gap needs to be at least 5% for you to even start thinking about doing a list experiment. That's about this trade-off between list experiments and direct questions. Right side panel is, let's think about list experiments alone. How big does the sensitivity bias have to be for us to even be confident about the results that we're getting? And this is power, statistical power to detect sensitivity bias. So in hypothetical simulations, when we know what the true prevalence rate is, we want to get the correct answer about 80% of the time. So above the line, the power is about is greater than 80%, which means that you should do a list experiment. Below the line, the power is less than 80%. You can still do a list experiment, but there is a chance that the results that you're observing, there's a chance that you are not observing a prevalence rate that's different from zero, when in the real world, there is a prevalence rate that's different from zero. So here, what we're saying is, if you have, again, 1,000 respondents, the sensitivity bias, the gap between direct questions and list experiment, has to be at least 15% for you to be confident on your list experiment. 15% of the people in your sample that would only give you honest answers if you use a list experiment. This is all to say, list experiments need very large samples, and those are not affordable for everyone, everywhere, especially in the social sciences. To make matters worse, this is not true for all sensitive attitudes, but it's true for a lot of them. The more sensitive they are, the more interesting or important they are for us to study. That means that they also tend to be more uncommon. This is especially true for what sociologists used to call deviant behaviors. And because they're more uncommon, they are harder to detect. So the things we care about them because they are rare and uncommon, and that's why they're sensitive, but they are important for us to study. So even if we're able to collect a lot of data, that doesn't mean that we're getting close to the people that we really want to understand. The same thing applies for a lot of sensitive attitudes and behaviors that are more prevalent among hard to reach populations. In a lot of the work that I'm doing now, it's people's interactions with criminal organizations in South America. And in that context, the problem is that we really don't know how to reach that people specifically. So we can ask the general population things about questions that are sensitive, but the people that we really want to know about, where we can sample them in a very reliable way. And that makes matters worse in terms of this bias learning trade-off. To make it matters even worse, if you care about multiple sensitive attitudes, which is very much often the case, that means that you need more of a sample. So we're talking about 1,000 being a good benchmark. If you care about more than just one sensitive attitude or behavior, make that 2,000 if you care about two, and so on. The same is true when you want to compare subgroup effects. So if you care not only about the general population estimate, but you want to get, say, different estimates by age brackets, you need even more data. So we say 1,000 is a good starting point, but in practice, it's going to be a lot more than 1,000. So very expensive, very hard to collect that data, very hard to even reach the people that you want to reach. All of this is to say that it's very hard to make list experiments work. What do we do? A solution that's been out there since pretty much list experiments were introduced to the social sciences is the idea of using double list experiments. The problem, and I'm hoping to convince you that this is a problem, is that it's very hard to implement double list experiments because you now have two lists. And having two lists makes things very complicated. So this is an example from a study that they did in California. And we have now two lists. There's list A and list B. And everyone sees both lists. So we have list A, list B, and these are different organizations, and they're asking people how many of these organizations you support. Again, don't tell me which ones, just tell me how many. I'm gonna take a second for people to read the organizations. And there is a mix of more left-leaning and right-leaning organizations, because the sensitive item of interest here is organization X, which is censored for ethical reasons in the actual study, but people got to see the actual name of the organization. But this is an organization that is advocating for immigration reduction and measures against undocumented immigration. The difference with a list experiment where only half of the people see this, the name of this organization, is that in a double list experiment, the name of this organization randomly appears in either list A or list B. This is equivalent to making two parallel list experiments. That means that we can calculate the prevalence rate in the way I described it before, by average the single list estimates of the list A and the list B. So for list A, we can calculate a prevalence rate. For list B, we can calculate a different prevalence rate, and we take the average of the two, and that's our population estimate. The advantage of this is that the variance or the confidence intervals of the estimates that we produce is reduced by roughly half. So this is again this is our estimate of the proportion of people who support organization X. List A gives you an answer that's somewhere between 20% and 50%, and that's a huge range. List B gives you something between 15% and maybe 45%. But if you put them together, which is the pool estimate all the way to the end, you get something that's between 25 and 38 or so, which is much more precise than what we had before. So this is good, right? We are getting a lot of improvement. This means that if before you needed 1,000 people, maybe now you can afford to have 500 at the cost of maybe just one extra question in your survey. But the challenge is that this variance reduction is not free. You now need to craft two baseline lists. This is costly because you have to make two lists that are comparable so that you can attribute the effects that you observe to the presence of the sensitive item and not to the difference between the lists. And this can go wrong. And the reason why I like to talk about this California study is because they had another sensitive item, which is called organization Y. This is a citizen border patrol group combating undocumented immigration. So they are similar to the previous group, but the previous group were just trying to lobby against immigration. These are people who are fighting immigration, taking matters on their own hands. So it's a little bit stronger of a treatment. So respondents in this survey were randomly assigned to see either X or Y. If they saw X, they never read or heard about Y, and the other way around. So these are mutually exclusive. We can think about this as two completely independent double list experiments. Everything else in the survey is the same. The list A and list B are the same. Everyone's being randomly assigned to list A, B in all these different ways. There's randomization throughout. So nothing else to change other than the fact that we now have organization Y instead of organization X. Yet the results are different. So what the problem is here is that from list A only, we don't know if that proportion is different from zero. You have confidence intervals that are overlapping with the dashed line there that is zero. List B is saying, well, there's maybe about 40% of the people who support this organization. And then when you pull these two together, you get an answer that's a little lower than 30%. Well, how do you believe this estimate? If one difference in means tells you, well, this is not different from zero, and the other one tells you it's maybe a little bit lower than 40, how can you believe the average of the two? What's going on here? Why is this happening? Everything else is the same. The baseline lists are the same. There's random assignment throughout. Any guesses in the room as to why we're seeing different patterns of estimates?
Are they seeing both lists? No, they're only seeing one, right?
Everyone sees list A and B. List A are always come first in this survey, and then they see list B.
So
What is changing is whether the organization appears in list A or in list B. And again, half of the people in the survey, they either see organization X first or second, or they see organization Y first or second.
possibly priming and going fast.
Yes. My point here, and what I'm building towards, is that it has to do with priming. The other answer is going fast, and there's a lot of research about what to do with people make non-strategic errors, which is not something that I'm going to talk about today, because there's a lot of research about what to do with those people. The difference could be by chance, just could be that you happen to sample people with the type of preferences that we observe, and that's a pattern that could normally occur if you do an experiment. Or it could be because organization Y stands out more than organization X, and that's where priming effects could come in. So to understand this a little bit more, we have to also understand that there are many different ways to do a double list experiment, and it has to do with the order in which lists are presented to people. So the example before, people always see list A first and then list B second. So that's what we would call a fixed list order, as opposed to randomized list order, when some people see A first and then B second. Some people see B first and then A second. Those are all, that would be a randomized list order. And then we can think the same about the location of the sensitive item. So it could be fixed. It could always appear first or second, or it could be randomized. It could flip between list A and list B. The fixed design here is not admissible. That's not even an experiment, because there is no random variation of anything. The randomized fixed design is the design that randomizes the order of lists. People either see list A or B first, and then the other one second. But the sensitive item always appears in the second list, and that's to avoid contamination across lists of priming effect or priming effects. So you usually want to do that because you want to avoid this type of priming, but perhaps you want to open yourself to the opportunity of seeing this priming or contamination, so you can detect it and diagnose it rather than avoiding it and being in trouble. So the last two designs, this fixed randomized design, the order of the list is fixed and the sensitive item moves around between lists. So that's the California study that I just showed you. And then the randomized design, lists are being randomly flipped, and the location of the sensitive item is randomly flipped as well. So these two designs, they give an opportunity to make statistical uncertainty statements about whether that weird pattern of estimates that we observe is systematic or random. And that's what that's what my work is building towards, is giving people tools to be more confident about the way they are designing their double list experiments. The intuition here, it's what I call carryover design effects. The fixed randomized and the randomized design have variation in what I call treatment schedules. So schedule 1 is you see the sensitive item in the first list. Schedule 2 is you see the sensitive item in the second list. If the sensitive item stands out, then respondents might alter responses to baseline items in unintended ways. So, for example, if you are in schedule 1, you see the sensitive item in the first list, you have the opportunity to change your answer to the first list and the second list. If you are in schedule 2, you see the sensitive item in the second list, you can only, in this case, deflate your responses to the second list only. Let me clarify this with an example. Seeing organization Y, this group that is fighting immigration by taking matters on their own hands, people who see that may think, wow, that group is standing out. I think this researcher cares about support for conservative organizations, and I think this researcher would judge me if I indirectly say yes to this organization. So if I'm a conservative, one thing that I would do in schedule 1, I would lie about supporting the American Family Association, which is a group that's advocating for pro-family values, and that I was on list A, and the Tea Party Patriots, which was another conservative organization that appears on list B. If I'm on schedule 2, I see the sensitive item only in the second list. I only get to lie about supporting the Tea Party Patriots in list B. I can lie about the American Family Association in list A, because I didn't know that the researcher cared about conservative organizations only until I got to see the organization Y in this case. So this is the type of carryover design effect that I'm talking about. And what this slide is showing is that this difference in schedules is leading to different empirical patterns of what we observe. And one thing to know is that this is true even if people do not support organization Y. Maybe especially so among those kind of people, because I might be a conservative respondent, but I understand that people should respect the law and not take law in their own hands. So I could support the American Family Association and the Tea Party Patriots, but I want to distance myself from organization Y. So what I'm going to do is deflate or decrease my real response to the list experiment questions, so that the researcher doesn't think that I am the crazy conservative who supports organization Y. I'm just a normal, reasonable conservative person. So the last thing I want to talk to you about is how to do this how we do test about these patterns statistically, and to make the distinction whether this is systematic or just random chance that this could happen. So the goal is to distinguish is carry over design effects from random chance. And we need 2 ingredients for this. We need the difference in means in schedule 1, and I'm going to call that tau 1. And we need the difference in means in schedule 2. I'm going to call that tau 2. The null hypothesis here, this is a statistical test in the intro to stats kind of way, is that the difference in means in schedule 1 is the same as the difference in means in schedule 2. If this is true, then there's no carryover design effects, and we can be very confident that the results that we're observing in our double-use experiment are because of the way we're assigning the sensitive item, and not because of the way in which we constructed the baseline lists. This is a very straightforward test. We compute p-values, which is the thing we care about to evaluate these tests, either with regression, because this is just a differences estimate, or with randomization inference, which is just we simulate the experiment multiple times and see what p-values we get. The only wrinkle here is that we need to account for the cluster structure of the data, because each person is giving us responses to 2 lists. So each respondent is its own cluster. So if you're doing this with regression, you have to cluster your standard errors. Which shouldn't be hard to do. So the results of applying this test to this experiment for organization X, which was the first one, for which we were very happy with the pattern of estimates we observed, and we saw there were more or less similar estimates for the independent list, and then they converged to a very nice and narrow estimate. The Difference in differences is only 0.08, that's less than 1 unit in this experiment questions. And the p-value is very large, so we don't have a lot of evidence against the null hypothesis for the organization X part of the study. For organization Y, we have a p-value that's 0.08. Depending on your discipline, you can say that's less than 0.1. I'm going to call that significant. In other disciplines, we would say, well, it's smaller for sure, but it's not smaller than 0.05, so I'm still in the air. But the point here is that we do see more evidence against the null hypothesis for organization Y. So that's giving us reason to think that maybe there are carryover design effects for the organization Y part of the experiment. And ideally, this is something that we can detect as we're planning the double use experiment. So we can maybe change the questionnaires and change the list so that we can avoid this type of problems. So generally, these tests are helping us to detect carryover design effects in this setting. Some additional considerations that are coming from doing more simulation work with this. This difference in difference test is very straightforward, but it tends to perform worse as the correlation between baseline lists increases. That means that if you try to make your two baseline lists very similar, and people usually want to do that because they want the results not to depend on the way they constructed the lists, but on the sensitive item. The test tends to perform worse. So this is a problem because the standard advice is to make correlated baseline lists. So the alternative is to use the sign rank test. And this is the point where if you're really interested in this, you should go and read my paper. But again, the problem of this sign rank test, which is non-parametric and has very nice properties, is that it has the highest positive rate to detect response inflation. I'm not going to talk about the difference between inflation and deflation right now, but there's a difference because this test has problems with people pretend to hold an attitude that they don't have, as opposed to people who are lying about not having an attitude that they do have. So the suggestion here is you can apply both tests perfectly fine, but maybe you should prefer some city items that are socially frowned upon. So for example, in the original Mississippi experiment, rather than asking people, did you vote yes, maybe ask them, did you vote no? So to wrap up, this is all to facilitate the implementation of double use experiments as opposed to list experiments. So if you are the person who's thinking about using list experiments to deal with sensitive questions, think about making it double. I want to flag that the cost of adding the extra question is not trivial. It might look like trivial, but it requires a lot of validation to make sure that you believe your answers, and the tests are helping you to navigate these choices. And these are choices that you should make at the pilot stage before you go on to the big survey with 1,000 people. So you feel confident about what you're doing. I think that's the main advantage of thinking about double use experiments this way. This is all compatible with other innovations to improve statistical precision to get narrower confidence intervals. What people are doing, they're using auxiliary information from direct questions, for example, to shrink those estimates a little bit more. And also something that touches on what I mentioned as non-strategic errors, people who are not paying attention, is maybe having a placebo-sensitive item in the control group, so that people are not simply straight lining and by an artifice of people always giving answers in the middle so that you have a positive prevalence rate, whereas there's nothing there. The placebo-sensitive item is making both treatment and control lists be the same length. So that at least for people who are answering in the middle, there's no effect. So that's all I have for you today. This is going to be useful for people watching this in video more than people who are watching this now. This is my email for feedback, and you can get a link for the slides and the actual paper if you want to learn more about this. Thank you all for your time, and hopefully there's enough time for us to have a conversation.
Thank you so much, Gustavo. We'll take a minute if anyone has questions. Again, please signal either with the online hand motion reaction things or in chat. I've got lots of questions, but I'll stick with one or two to start. Because I often work with very vulnerable populations, the issue of being able to access the population becomes huge. And so I began thinking a lot more about online communities and kind of relaxing geography to be able to find people that have similar circumstances to be able to get that kind of high end. And so I'm curious, I know all of the issues that come up in online survey development. I haven't seen anything about double list experiments within online surveys. Do you have any thoughts or experience with that?
A little bit for other people who have worked on this. In my own work, and I've done a lot of studies with student samples because they're easy to access, mostly because one thing I care about is how can we design better lists. One thing that I've noticed with student populations doing this online is that they don't care about they have no filter and nothing is sensitive for them. So if you ask them the question directly, or if you ask them in a list experiment, you don't see the answers are the same. And if you're in that situation, usually that's not a problem, and it's better to be cautious about things that might be sensitive, and if they're not, rather than the other way around. The other side of the coin, the other argument that I've heard is that the reason why questions are sensitive is not because questions are sensitive, but because context are sensitive. So a lot of that, it disappears online. And I think a reason why a lot of the people, the reason why we don't see a lot of work out there with experiments with online samples, or we see very much fewer pieces to doing that, it's because when you're answering this online, people don't have a sense of someone's judging me, someone's going to know the answer, because we usually start this online survey saying your answer is anonymous. If you want to quit the study at any point, you can do so. So usually the people we are left out with are the people who really don't have a problem giving you the answers you want. And that should give us pause, because maybe the people we really care about, if these are vulnerable populations, is the people who are not even taking the survey.
Right.
So I don't have any good answer or suggestion for that, other than one, think about how to make people feel safe about taking the surveys, and two, think about how to project the questions of the people that you can survey to the entire population of interest. So make the exercise of saying, well, we're only seeing 10% of the people having this sensitive attitude, but if I was able to sample all of the people that I care about, is this going to be bigger? Is this going to be smaller? So put some context on how we are reading the findings.
It strikes me too that potentially they could be used for exclusion criteria if you were to believe that online you might get a lot of people wanting to respond that aren't part of your population of interest. That you could think of items of response that would be very likely amongst your population of interest, and do a double list to be able to filter out responses that may not be sort of legitimate parts of your population. Since certainly that is one of the kind of issues around lying that comes up a lot in online surveys.
And one of the things we assume here when we do list experiments is that people only lie about not having the sensitive behavior when they do, but we never we are assuming that people are not lying about telling you something they don't have. And I
That's
think that's something that might happen with online samples is, if you ask people something that's too sensitive, they can be like, oh, that's silly. Of course I've done that. So the answer, yes, implicitly, the list experiment, even though they don't, and that's completely breaking the list experiment because we don't expect people to do that. I like the arrive can example because that's a case in which when you see these questions in the real world, no one's going to be like, yes, I have COVID, don't let me in. But in online studies, that we can see that, and we should think about ways to do that. I don't think I've seen anything about how the double list experiments can help with that. My intuition is because you have more questions, you have like more opportunities for those people to not just fool around in the survey, or to at least screen those people who are just fooling around.
Yeah.
But I think it would be nice to focus on that type of behavior that's breaking the identification assumptions of the list experiments, and see if having the double setting is helping us weed out those people who are not the people we care about at all, but they look like they are, because this is an online survey and people can do whatever they want.
Michelle has a question. So now that most surveys are online, we tend to increasingly concerned about inattentive respondents who aren't paying attention. This approach of the list experiments seems to assume that people are hypersensitive to standout sensitive items. So if people aren't hypersensitive and they're not paying attention, you talked about this with young people, is just not caring. Maybe we don't need the double list experiments, or how do we balance these concerns about attention versus inattention? And I guess with that, whether a double list experiment is warranted.
Yeah, so this is a great question, because I think this is the core of what we were talking about, and I was going there before we read the question. So this has two parts. That the attention inattention part, there's nothing we can do about inattention within list experiments that we shouldn't already do for inattention with surveys in general. So asking screener questions, this is true for all experiments and surveys, which we could ask a screener question that is a practice question to see if people are getting it, to see if people are giving you the right answer, and that so that even before we do the experiment, we can say, you probably didn't pay attention to the practice questions, so you probably are not going to pay attention to the list experiment questions, and ideally we want to catch those people before they go and take experiments. So those are called mock vignettes. One thing that you can do within these experiments is what I mentioned about having placebo sensitive items in the control groups, and this is especially good in the double list experiment, because then all the lists are the same length. So people who are reading things very carefully, they're not just thinking, well, the first list was 4 and this second list is 5, so there is something going on here. And then going back to the question about what's sensitive here and how do we do this in online surveys. So the traditional reason why we want to ask indirect questions for sensitive responses is because of anonymity. This is all we're all starting. This is where I started my talk talking about that. I think the main reason why we should think about this is in online surveys. It's not because of the behaviors being sensitive themselves, but because how you include the sensitive item changes how the list reads. So one example could be, if I have a list of foods and I live in or take out hamburgers from the list of foods, the list can change from a list of food versus a list of unhealthy food. And those are two different lists altogether. And it's not necessarily changing how people perceive the question as sensitive or not. So it's not a question about people feeling like their privacy is being protected or not. It has to do with the fact that having that one extra item can change how the whole read lists. So in the example of the California study, maybe having that one extra organization it's making people realize, oh, this researcher cares about conservative organizations. And then is when the sensitive behaviors start to trickle in. So usually when we think about when we think this doesn't apply to online samples, we tend to think about it because we think about there has to be a reference for people to make this sensitive. So there's an enumerator who is listening to my questions, either on the phone or in person, and they might be judging me. If I'm in a place where democracy is on the thread, maybe I'm thinking someone's gonna get to know my answer to these questions anyway. So I don't feel safe just giving you an honest answer unless you ask things indirectly in a way that I don't notice. So that's usually the theory of why you should ask indirect questions. I think something that's more important now with online surveys, and I think this is the reason why I'm pushing this agenda. It's because it has more to do with how having the sensitive item changes the treatment of the whole list together, as opposed to having this reference of there's a third person or a third party who would know my answer if they ask me the question directly. So questions should be asked indirectly. So hopefully that answers the critique of like, why should we care about this if we are in a world where all the surveys are online anyway?
Thank you so much. Any other last questions? We're just a little bit over time. All right, well, thank you so much for joining us, Gustavo. I put into the chat a link for a quick feedback form. We take this very seriously and are always looking for what it is that researchers are interested in and the kinds of methods that you're working with that we can help to bring expertise of people that have been exploring with those methods for a while to the fore. So thank you all for joining us. Thank you, Gustavo, and have a wonderful Thanksgiving weekend, everyone.